All right, so let's say we have to find the shortest distance from the point 1, 0, negative 2 to the plane x plus 2y plus z equals 4. On previous problem where the boundary point, local mins or maxes, no, remember the only local min or max potentially would be the critical point. Yeah, so the local maxes and mins would come out of your critical points. All right, so this, of course, we're using the distance formula here just in 3 dimensions. So if you've got the distance from x, y, z to the point 1, 0, negative 2, what do you got? Square root of the x minus 1 squared, y minus 0 squared, plus z plus 2 squared, okay? That's for any point. Now, we want the point, though, to have the special restriction, x plus 2y plus z equals 4 from that plane. And so what we can do to utilize the things we're talking about here, how about we get this in, one way we can do it is get this in terms of x and y, and then use our critical points and that sort of thing on it. And so if we solve this for z, z would equal 4 minus x minus 2y. Then we can plug that in for z, and we have a function that one's y squared. And then this would be 4 minus x minus 2y plus 2, which that would be what? 6 minus x minus 2y squared. Okay? Now, like I said, we're trying to find our maximum minimum off of this. And so what we need to look for are the critical points for local max or min. Yeah, and so we do some partials. Now, the book points out that this is going to be a complicated one, even if we're just doing partials, because of the square root. If we factor that in, it would be to the 1/2, and you'd have to do a negative 1/2 power, which is going to flip it to the denominator. However, if you think about this, this is these are all positive numbers. So it's like we've got the square root of something positive. Let's just say it's x squared plus y squared. And so when we do the derivative of that, whatever partial you want, you are going to get this. Okay? But their point is this. Or one thing we could, we're just interested where that equals 0, right? And so really this is not going to come into play at all. So here's what they say. Let's just do d squared. Yeah, well, let's just square both sides, and then yeah, and so you have the same. I erased my example, but So z squared, won't it have the same critical points as that? Won't those have the same critical points? Because that this one just amounted to this for the partial with respect to x. But you set that equal to 0, you're still going to do the same thing as, you're still going to get the same partial set to 0 here. So anyway, okay. Just a slight little point there. Basically forget the square root. You don't have to worry about that. So let's call that our, our function. And so the partial with respect to x would be what? Well, it would be 2 times x minus 1 plus 1 times 6 minus x minus 2y times negative 1, right? Oops. Yeah. Just a little power rule, right? Which is 2x minus 2, and that would be minus 2, so it would be minus 12 plus 2x plus 4y, which is 4x plus 4y minus 14. And we're going to set that to 0. And the only problem is that's not going to give us an x and a y value, is it? Or an x value, like sometimes it does. So let's see what we get for the partial with respect to y. Partial with respect to y of this would be 2y plus 2 times 6 minus x minus 2y to the first, times the derivative of the inside with respect to y would be negative 2. And so that will be 2y plus 12 minus 2x minus 4y whoops, sorry. 2y, I forgot my, this will be minus 4, won't it? Times 6 minus x minus 2y. So that would be minus 24 plus 4x plus 8y. Yeah. It would be 4x plus 10y minus 24. All right. So yeah, we have to solve a system to get our critical numbers right there. So looks like we could do a quick solve for x, couldn't we? Because yeah, we've got 4x minus 4x. So just subtract whichever one you want to. So that'd be negative 6y. I guess I should have gone the other way. No, it doesn't matter. Plus 10 equals 0. So it'd be positive 24 minus 14. So that'd be y equals negative 10 over negative 6, 5/3. So the y would be 5/3, which would put the x at what? Be 4x plus 20/3 minus 14 equals 0. Yeah, these are probably not going to be nice, easy numbers. Usually. Let's see. So see, that would be 20. X is 11 over 6. Okay. So what does that mean? Oh, okay. Now, just to verify here, and to rethink some other things we've had, we could show this is a minimum using our second derivative test, right? So let's think about that, because we're looking at the point 11/6, 5/3 as potentially a minimum. If we go to our second derivative test, with the second derivatives, fxx would be, turns out they're pretty easy. The second derivative of x with respect to x would be we're just differentiating fx would be 4. Fyy would also be 4. And fxy would be 4, right? It's always 4. Well, so if we did the fx with respect to y, so that would. All right, so what we get there is our d of fxy dxy is, I think I can erase this. I mean, I should erase that, but it's not coming out. Derivative, second derivative, or second partial derivative with respect to x is 4. Second derivative with respect to y is 4. Why is that? Should be coming out to 24. Oh, that's what it is. Okay. It's right here. This is what I missed. The partial of f with respect to y, the second partial fyy, so we're doing this one with respect to y. It's not 4, it's 10. Right? Yeah, okay. Okay. That's what was throwing me off. All right, so fxy, dfxy, remember you do fxx times fyy minus fxy squared, 40 minus 16, which is 24, which is greater than 0. And so, depending on fxx, what do we got fxx? It's greater than 0, which means the concavity is up, like that. So it is a minimum, isn't it? So you have a local min at your critical number, okay? And, this does have a minimum point shortest distance from the point, that's obviously going to happen from, you got a plane, you got this plane, and then you got a point up here, wherever it is. Well, there's got to be some, so that I mean, it's local min, but it's also going to be an absolute min, so it's going to have a shortest distance. So anyway, so the shortest distance would be it would be D equals, plug in the 11, what was it, 5/3, 11/6? Or this is where I wish I had a bigger forward space, okay. 11/6, 5/3. Okay, so we plug that in, we have 11/6 minus 1 squared plus 5/3 squared plus 6 minus 11/6 minus 2 times 5/3 squared. Okay. That would be 5/6, all right, squared plus 5/3 squared plus, this would be 6, which is 36/6 minus 11/6 minus 10/3 would be 26. So it'd be 5/6 squared. And let's see, 25 over 36 plus 25 over 9 plus 25 over 36. Looks like we need a 36, doesn't it? Multiply that by 4, so it'll be 100 over 36. 25 over 36, so 150 over 36. So square root of 36 is 6. So the square root of 150, 25 and 5, or 25 and 6. 25 and 6, right? So it'll be 5 over square root of 6 over 6.